All right, so this video is going to be about z-scores and probability. You're basically going to be trying to find the probability of landing between like two specific scores or one score, above, below. We already did stuff like this. Remember, it's when we broke up into like a bunch of different sections depending on the standard deviation, and then each section had a percent. Had a percent, so 34, and then it was like 13.5, and then 235, and then 0.15. So all of these, it's to basically figure out percentages of people, and how it really works. But now remember, we're going to be working with z-scores. Okay. And z-scores, you have basically the same exact graph, like the same bell-shaped curve. It has a different name, right? And it's just adopted, and the name is the standard normal curve. So whenever you think or you hear standard normal curve, automatically it's the bell-shaped curve. Automatically, in the center. Now this is where it changes a little bit, right? Because in the normal curve, we know that in the center, it's going to be the average or the mean, and then it's going to either increase by the standard deviation or decrease by the standard deviation in both sides. Now, for the standard normal curve, basically everything's going to be the same, right? This is going to be positive standard deviations, and then on the left side is going to be negative standard deviations. But now the only thing though is we are going to completely relabel it, okay? So we're just going to always take for the mean to be 0, and the standard deviation is always 1. All right, so technically it's going to have like really basic numbers. So this is always 0, and then it's going to be 1 standard deviation away, 2, 3. And then if you go to the left, remember it's going to be a negative standard deviations because you're going in the opposite direction. Okay? And so I need you to really understand one important thing. Why is the average 0? This standard normal curve has to deal 100% with z-scores. Okay, so since it's with z-scores, technically all of these are what you can get as a z-score. So for instance, right down the middle, the one that used to be the average, now we call it to be 0. Well, that's 0 because what that means is that the z-score is equal to 0. So you're exactly average, right? If you remember that equation for z-score, right? It's a raw score minus average all over standard deviation. So in order for this to be 0, that just means your average is the same as your raw score, okay? So that's why this here is 0. And then we're just going to go 1, 2, 3 in this direction, just because you're basically, it's how far away you are from the average when you take it into consideration with standard deviation, right? That's what a z-score is. And so let's go ahead, and if you really want to, right, this is how it looks. It's pretty much the same drawing that I did there. One thing that I will have you understand is that the standard deviation is the same exact thing, okay? You're just, instead of going, this here basically is graphing or not graphing, but you're visualizing where your raw score is at in relation to the average, okay? And this graph here basically is going to be just your z-score, okay? And that's really nice because if you already know your z-score, just based off of the equation of the z-score and the understanding of it, you know how well you did in relation to the average, right? You don't have to be told, oh, well, 100 is the average. No, if your z-score is, automatically negative, that means, you scored lower than the average. And depending on what the decimal is, that's how far away you are from the average itself when you consider the standard deviations. So this is a really nice thing because it will never change when we talk about standard normal curve, okay? So the standard normal curve works with z-scores, okay? It's always going to look like this, and then it's really nice because the percentages are basically the exact same thing as before, right? You don't have to basically learn something else here. Now, one really interesting thing, though, is when you consider that a z-score can also be a decimal. Now, this is where basically this graph and a table comes into play like a lot. So just really quickly, just so you won't forget the percentages or what it really means, let's go ahead and let's do this example. Let's just understand what it's saying. So suppose Tara's z-score on her final was a 1.0. So that means her z-score is 1.00. Remember in the previous videos, right? That looks like 6. So So remember in the previous videos, I always say, give me two decimal places. Once I get to the third example, you're gonna understand why 100%. So it's 1. So how well did she do? Well, obviously she scored a positive z-score. So therefore that means she scored higher than the average, right? That's one thing that we know. And now let's look at these questions right here. What percent of people scored lower than Tara, and then what percent scored higher? So what we really could do is we're gonna now draw the standard normal curve, right? Where this is 0 and this is 1, 2, 3, and then -1, -2, -3. Remember, there's other numbers, right? It doesn't always have to stop at -3 or negative or +3, but just you're gonna see when we understand percentages more, it's really, you don't have to consider it that much. And so let's see, so her score was a 1.0, so that means this is where she lands right here. Okay. Now the question is asking what percent of people scored lower than Tara. Okay, so to get lower than Tara, you're going to have to include all of these percentages here because that means that they scored lower, okay? And so then just from remembering the normal curve numbers and the percentages, we know this one is 34, 34, this is 13.5, this is 13.5, 2.35, 2.35, and then the last one is 0.15, and then 0.15. But a really nice, lazy way to view it is you have to understand that this here cuts it exactly, 50% this side, 50% this side. And so if you notice, the 1 is just one extra section of it. So technically to get this answer, we could easily just do 50% plus. So that will take into account all of these. Here, let me choose a different color. That'll take into account all of these. That's 50% plus this extra 34 there. And so then that'll give me 84%. And so what percent of people scored lower than Tara? 84%. And now to figure out the other answer, which is what percent of people scored higher than Tara. So, I mean, you can do this two different ways, right? Higher means, you score to the right of it. So let me go ahead and let me get rid of some of this here. All right, so if we're talking about scored higher, let me just erase that one because it's bugging me. Okay, there you go. So higher than Tara, that means we're going to be going with this side over here on the right. So that means we'd be adding these three numbers if you want to. Or you can also just kind of just do the entire curve is 100%. So that's everything. Okay. We know that 84% of people scored lower than Tara. And so then just to figure out the other percentage, we can just do 100 or 84. Sorry, 100% minus 84%, and then that'll give us our answer, which is going to be 16%. So, I mean, you're really just figuring this out, all how you can do it, I guess. One thing I will say, though, is, let's see, if you were to add these three, would it give you exactly 16%? I do think so. So, yeah, that's fine. All right, so that's how you would do it with a z-score, right? And questions like this. It's very simple, and one of the reasons why this example is simple is because the z-score is perfectly lands on one of the boundaries that we've established already. So same exact thing. This here question is talking about the weight of a preemie. I'm not even sure if that's the right word, but a preemie baby is a baby that didn't take 9 months. It was born before the 9 months and stuff like that. So the z-score is a -2. See if you can first question is it above average or below, and then what percent of babies weigh less, what percent of babies weigh more. So go ahead, pause the video and see if you can come up with the answer. For those of you guys giving this a try, all right, really quickly, z-score is -2.00. Okay, it's important to have the two decimal places. Right now, not so much, but once we get to the next example, you'll see it. Since it's negative, automatically is the weight above or below? It's going to be below. Automatically because it's a negative z-score. Okay, sorry, that should say z-score. And now let's see for the next question. What percent of babies weigh less? So that just means I need to know where does it fall here on the standard normal curve. We know that this is 0. It's -2, so technically it's -2 right there in this one. And so this first question weighs less, so that means you are looking for this side of the curve. And then what percent of babies weigh more? So that means you're looking at the other side of the curve. Okay. So it's up to you how you want to do this. You just have to remember how the standard normal curve breaks up. So 1, 2. So let me just remind myself. So this is 34%. This is 12 point. See, I even forget already. Is it? I think it's 13.5%, and then 2.35, and then the last one is 0.15. So technically, it's only like two sections. Right, technically it's only two sections, which is going to be the 0.15 and the 2.35. So let me just clean this up a bit. So then it'll be 0.15 plus 2.35, and then that right there will give us our answer for what percent of babies weigh less. And then if you really think about it, let's just think about what the number is saying. So let's see, that is going to be equal to, what is that? 2.50. All right, let me just make sure. 3, 4, 5. All right, cool. So 2.50%. So the question is asking what percent of babies weigh less than this particular baby, and this particular baby already is like super, below average, and so there's just a little bit of babies below average, and so that's where we get the 2.15. That's why the number is just so low already to begin with. And then what percent of babies weigh more? Well, I'm gonna go ahead and do the little 100% minus trick, just because it's technically considered to be the shortcut. So it'll be 100% minus 2.50%. And the reason why this works is just because you have one boundary. So if you really think about it, right, you have one boundary, and if you have this side here, this left side, then, and everything underneath that curve is 100%, then you can obviously figure out the other section as well. So that's just how that shortcut works. Okay, so then that'll be 97.50%. And then once again, right, you have to make sure you try to understand why the answer is so big. So large. The preemies, they weigh way less than the average. And so then there's obviously going to be a lot more babies that weigh more than this particular baby, right? Because the Z-score is just so low. So net 97.50%, okay? And so now let's actually get to a really, really good example of how Z-scores are super important and why they're used a little bit more, I guess. So in on previous videos on how to calculate Z-scores, I hope you notice that most of them are technically decimals, right? They're 1 point something, 1.23, 1 point or negative 2.40, whatever. But my whole point is they're decimals. And so this kind of like breaks the standard normal curve down a little bit, because if you notice, this is going in increments of integers, right? You have 1, 2, 3, and then -1, -2, -3. And so what actually happens when a z-score is a decimal that is not an integer, and it actually does happen, and it happens quite frequently. And so let's see for this one here, it's 0.34, so it'll technically land somewhere like right there. So that's the 0.34. But now the question becomes, how do I know? So I obviously know that it's 50% plus this little itty bitty section of percent right here. But my question now is, how do we figure this out? And we actually are not going to have to figure it out. We're going to use something, we're going to use sort of this the z-score table, if you really want to think about it, okay? So just really understand, okay? So what percent of people scored lower than cat? Well, it's going to be a little bit more than 50%, but I don't know. Is it 51, 52, 53, whatever? Because my biggest point is we just don't know. And then what percent of people scored higher than cat? Again, we can't figure it out. We can obviously figure out these three sections, but then here, this section, it's not 34. It's a number smaller than 34. I just don't know how much smaller. And so then what actually ends up happening here is we're going to be using this table here. And for those of you guys that are already looking at the Canvas page, you download this table. If you have a printer, you can print it out, but if you don't, that's fine. So, and then for those of you guys that are looking at it on the YouTube, I don't know, site or whatever, I'm gonna link a web page to the description, and where you can see this table here. And then let me just explain what's going on here and how to read it. Okay, so the standard normal probabilities, that's what they call this table. For me, I'm just going to call it the z-score table, because it basically is using only z-scores. So if you notice, boom, right there is z-scores. Now, what you need to understand here is this table, it's I sort of cut it here just so you can see, the top part and then the bottom part. So there's just a ton more numbers here in the middle, okay? So what this z-score table is telling us think of it as like the percent that is below that z score. So if you notice, it's shading in the left side of the z score. So read this sentence here. It says table entry for z is the area under the standard normal curve to the left. Okay, so you're basically, this is like the smaller than section here that we're talking about. One of the pages is going to be all the negative numbers that you can think of for the z-score. And then the other page is going to be all the positive numbers. Okay, because you have to think about where these are coming from. Okay, so let's just do this real fast. Okay, so this is the center, it's 0. All on the left here are the negative numbers, and that is the first page. And then all on the right are the positive numbers, and then that's going to be the second page. And so let me go ahead and explain how to technically read this with the first example. So with this example here, with 0.34, okay? So 0.34, technically it's a positive number, so that means we need to be looking at the page where it has positive z-scores. And this is what you're going to end up doing, 0.34. This is going to be broken up into 2 sections technically. You're going to go ahead and do the whole number in the front, the decimal, and then the tenths. So for this case, it's 0.3, and then the hundredths, which is going to be 0.04. So basically, this is going to be 0 all the time, and then you're just going to take the second number and then put it there. Okay, so that's how it's going to work. It's going to be broken up into 2 sections. Okay. Now, the way to do it is you're going to look for 0.3 here in this side, and then you're going to look for the 0.04 up here on the top, and then you're just going to look at where they intersect. So let me kind of zoom in for those of you guys that need to see it, and I think I have it right here. Yeah, let me zoom in. Okay, so this is how to break it up. 0.3 is found right here on the left hand side. So if you have it printed out in front of you, you can go ahead and make a line through it or circle or whatever. And then you're going to find 0.4 up on the top, which we can find right here. And then you're just going to highlight all of them, or, you're basically just looking for an intersection. And I hope you can see where they intersect right there at 0.6331. And now the really nice part about it is that you need to understand what this percentage is, or sorry, what this decimal represents. So these are all decimal series, but we could turn them into percentages by, just moving the decimal point 2 places over. So this here is technically 63.31%. Okay. Now you have to remember that this table here, the one that I linked to you and the one that I have for you, gives you the left hand side of that z-score. So let me go ahead and let me try to explain it. So 0.34, remember, that's the z-score that I gave you from the beginning. Okay, so here goes my standard normal curve. There goes the 0. And then remember, where would the 0.34 go? So if we recall, it'll go 1, 2, 3, and then -1, -2, -3. And then the 0.34 would go like right there. Just imagine it's a straight line. Now, what this 63.31% means is it's telling us all this percentage already. So it's basically like adding it up for us already. And that's why this table is so nice. Okay, so that means this side is going to be 63.31%. And then you can obviously calculate the other side just by doing the trick, the 100 minus 63.31%. So that's what I'm going to go ahead and write. 100 minus 63.31%. And so that's how you would read it. And so now you just have to go back to the question and really understand what's going on here. Okay, so let's go back to the question. What percent of people scored lower than Kat? So you have to remember, Kat's score was a z-score was a 0.34. All right, 0.34 right here. The z-score table tells us that this percent is 63.31, and then just using basic math, we can figure out the other one. So Scored lower is going to be the side that basically the z-score table gives us. So then we already have that answer. It'll be 63.1%. And then there you go. That's pretty much all you have to like learn how to do with the new table. And then what percent of people scored higher than cat? Well, we want to figure out this side for that question basically. So it'd be 100 minus 63.31. There are some tables that give you the right side of the z-score, and then there's some tables that give you the left side. The table that I provided for you guys will give you the left, and that's the one that you should be using for this class, okay? Oh, it was 31%. I forgot the one there. I think I converted to thing. All right, so then that's all you have to do here, and then you just get your calculator and figure that out. Let me see if I can do this by hand. So it'd be 1 9, it'd be 6. Is that 36.69%? Let me just check that. I think so. 9 0 okay, 1 3 4. All right, cool. So there you go. That is my two answers, and that's all you really have to do. If you're given the z-score, you can just find it on the table, and then that's it. So really the biggest thing for this is just learning how to read the z-score z-score table. It's called the standard normal probabilities table or whatever. Just it's broken up into the negatives and the positives, and then you just have to use always two decimal places. That's the biggest thing, okay? So let me go ahead with the next example and see if you can kind of figure out how to do this. Okay, so I hope you gave these a try. And remember, you need to have the z-score table in front of you for the rest of these problems, because the z-scores are going to be, decimals. So for the first one, in the table, where were you able to find 0.9406? Now, you do need to understand this is technically 94.06%. So, just be smart about where you look for this. You have two pages in the z-score table, right? The first page is where all the z-scores are negative numbers. Okay, and then the second page is where the z-score is a positive number. Now, you need to be smart about it. Think about it. This here in the middle is exactly the z-score of a 0, and you know that 50% lies on this side, and then the other 50% lies on this side. But in total, it equals to 100. Where would you find the 90s technically? You would find them somewhere over here, because then you have to consider the table uses the left side, okay? So that means this here would be the 94%. So you're obviously looking for a positive z-score. So just looking for those little shortcuts. So once you look through the z-score, I believe that it should be 1.56. Now remember, right, the z-score table has two different sets that you need to look at. The numbers on the left side and then the numbers on the top. Okay, the numbers on the left side basically give us the integer plus the tenths, and then the numbers on the top of the table gives us the hundreds. All right, in the next problem, it says find the z-score so that the area to the left is 10.75%. So after looking through the z-score table, you should have gotten negative 1.24. Let's see, the next one says find the z-score so that the area to the left is 0.8810. Again, that's looking at the z-score table and just realizing it's at 1.18. And then finally, find the z-score so that the area to the left is 0.9881, and then that'll give you at 2.26. So you have to really just have the z-score table in front of you. That's one of the major, things that you need to have in front of you, or at least opened up in a different tab or anything like that. So let me actually, give you an example of how you would use this, completely. Okay, so let's go ahead, pause the video, see if you can do it by yourself if you want to, but let's see how we get through this. Okay, so in this one, let's go ahead and let's read it. It says a shoe manufacturer collected data regarding men's shoe sizes and found that the distribution sizes exactly fits a normal curve. See, that right there already tells us, we can use this little curve thing. If the mean shoe size is 11 and the standard deviation is 1.5, okay, what is the z-score for shoe size 9.5? All right, so first thing we need to do here is remember the equation for z-score. So for the equation for z-score is raw score minus average over standard deviation. Now let's see, what is the z-score for a shoe size of 9.5? 9.5 is the raw score, 11 is the average, and 1.5 is the standard deviation. So then the equation would technically be what is that? 9.5 minus 11 over 1.5. After we plug that into the calculator, we get negative 1.00. Okay, so that is the z-score. Z-score is negative 1.00. Now, what is the probability of randomly selecting a man with a shoe size smaller than 9.5? So let's look at the z-score table. So it's negative 1.00. So then I have to, here goes a little part of the table here. So let's see, z-score is negative 1.00. So what we can do is, remember, we break it up into two sections with the integer in the front, decimal, and then the tenths place. And then the other one is going to be always 0.0 first, and then you just take the second number and you just bring it down. So it's 0.00. I know right now this is a little bit overkill, but this is what you need to do, okay? So for this side, the integer plus decimal plus the tenths, that's what you're going to find over here on the left. So it's negative 1.0. So let me go ahead and let's find it. Negative 1.0, which is right there. Okay. And then the next one, it's 0.00, which is the first one. So that's fine. And then all we have to see is where do they intersect, and that'll be right there. Okay. So that's how you read this table. So it'll be 0.1587. Okay, so it'll be 0.1587. This is the area, you have to remember, of the curve where it is negative 1 is here for the z-score. Technically, it's going to be the left side of it, okay? So that's what you really need to understand. Sorry, that doesn't even look like an arrow, but that's the arrow there. The yellow filled in place is the left side of the negative 1 z-score, okay? So 1587. Let's go back to this problem. Let me zoom out a little bit. 15.87, just so I don't forget. 15.87%. That is the left-hand side, okay? So let's see. What is the probability of random selecting a man with a shoe size smaller? Okay, so smaller, that means to the left. So then that means this here is going to actually be the answer, 15.87%. So let's see the next question. If we surveyed 40 men, how many would be expected to wear smaller than 9.5? Well, we already know it's 15.87% of those people. And now, since they actually gave us a number, we can actually just do it. It'll be 15.87% of 40 men. And so we can just easily calculate this by, changing it back into a decimal, which is, I believe, the reason why in the table it already gives it to you as a decimal, but honestly, I don't really know. So then we would just multiply those two numbers, and then that'll be the answer for that. And so I'm gonna go ahead and grab a calculator for that. So it'll be, let me see, it'll be 40 times 0.1587, or the other way around, it doesn't really matter. It'll be 6.348. So 6.348. We're talking about how many would be expected to wear smaller. I mean, you can't really say 6.348 men. You can just round. We'll just say, I don't know, we'll just say 6 men. Okay? And then there you go. Just round it to a whole number if we're talking about like actual people and stuff. If it was like scores or time or anything, then the decimal would make sense. All right, the next question is, what is the probability of randomly selecting a man with the shoe size greater than 9.5? Okay, so then here you go. This is what you just have to, make this problem super not hard on you. If 15.87 is the percent of it being less than 9.5, then you can obviously calculate the more by just doing, the kind of like the opposite of it. The entire curve is 100, and you want to know what's the other. So it'd be minus 15.87%. Sorry, those are like sixes, but they're percent sign or whatever. Let's see if I can do this in my head. It would be 31.48. Let's see if that's correct. 5. All right, cool. And so there you go. That would be the answer for letter D. Okay, so let's go ahead and move on to the next example. Just a little quick heads up, right? This here is my advice for some of those problems, okay? Yeah, so convert the data into a z-score if it's not given to you already, and then you look for that in the z-score table. Make sure you guys are reading the keywords, basically. That's the most important part. Keywords, is it greater than, less than? Are they looking for the left side of the curve or the right side of the curve? Understand, right? The table I gave you, or the one that I linked, that is the left side. Okay, that is the left side of the curve. So just be aware of that. There are different tables as well, so just be careful. I would say look at the shading, right? Because it's the left side, you're going to see this here shaded. All right, so just be aware of that. And then either use the percentage given in the data table or subtract from 100. That depends on, is it asking for the left side or the right side, things like that. All right, so go ahead with this next example. See if you can do it by yourself, okay? Pause the video. It's completely fine, okay? Just think of the advice that I just gave you right now, okay? All right, so for this example, let's go ahead and let's read it. Suppose the heights in inches of adult females in the US are normally distributed. All right, so all that means is that we can go ahead and use that curve, the normal curve, okay? So with the mean of 64.1, all right, so mean of 64.1, and then a standard deviation of 2.75, right? So we have that information there. It says, find the percent of women who are less than or equal to, so that already means to the left, okay? That's what that means, to 61.6 inches tall. All right, so there's a couple of ways we can do this. We can try and see if, like, do we need to even convert into a z-score, okay? And the way to do that is we can just set up our normal curve and then see, does this 61.6 land perfectly in one of those like 1 2 3 away, or 1 2 3 away on the other side. So if the mean is 64.1 and the standard deviation is 2.75, all I have to do is subtract, right, to get to the next number, to get to basically like this next number here. And so it'll be a 64.1 minus 2.75, and that one will give us, it'll give us 61.35. Okay, so if you notice that there is not this number, so that basically is your like telltale sign of I need to use z-scores. If it doesn't perfectly fall into one of like the the standard deviations away for the normal curve, then like automatically that's where you would have to use z-scores, because we can't find the percentage, right, if you don't know exactly where it lands, or if you don't know the percentages. So what I'm going to go ahead and do is do that first. I'm going to convert it to a z-score, okay? So z-score, for those of you guys, the formula. You should have this formula written down, or, either memorized at this point, just because you've been using it for a little bit, okay? So that right there, it's raw score minus mean over standard deviation. So for this problem, the raw score, or the raw height that we're talking about, is 61.6. So it'll be 61.6 minus the median, or sorry, the mean, which is 64.1. Sorry, and then all over the standard deviation, which is 2.75. Yeah, I know it looks really messy, but whatever. All right, so we bring that down, and what is that equal to? Remember, this is the z-score. So now this is totally calculator time. All right, so let's see. It is 61.6 minus 64.1, and then that all over 2.75. And so there you go. The answer is a really, really long decimal. So it's negative 0.9090, and then it just keeps repeating. And so you have to remember, right? For z-scores, you always want 2 decimal places after. Okay, so you need to go to the, what is it called? Hundredths. And now to do that, basically the 0, it depends on the number right next to it. Right? If it's greater than 5, you go up. If it's less than 5, then you just stay. So the z-score that I'm going to stay with this problem is negative 0.91. Okay, that is the z-score for this problem. Negative 0.91. And so now all I need to see to answer basically this, to answer letter A, is just let me find the z-score on the table, and then that's going to give me the left, because it's the table for the left, and then I'll be done with A basically. So z-score of negative 0.91. Since it's a negative, I already have here the negative page, okay? So let me just remind myself, negative 0.91. Remember, you break it up into 2 sections, basically. The first one is going to be the integer plus the tenths place, and then the second one is going to be the second number. Remember, it's always going to be 0.0, and then you just bring that number down. So it's going to be a 1. Okay, so these are the 2 numbers to look for in the table. Negative 0.9 you would find on this side, And so we find that negative 0.9 is right there. And then to find the 0.01, we would just find it up here on top, which is this one. And then all we have to do now is look at where they intersect. And they intersect right there at 0.1814. Okay, so let me write that down before I forget. So it's going to be at 0.1814, which, if I change it into a percent, I just have to move the decimal places over twice. So it'd be 18.14%. And it makes sense. It makes sense just because you're on the left side, you're going away from the mean. So then obviously the percentage is just way less. Okay. So 18.14%. So that's the answer. Okay. Remember, think about that. All right. So find the percent of women who are less than or equal to this z-score, because remember, we just basically, instead of using the actual raw data, we're going to use a z-score now. So it's to the left because it's less than. So then the answer that we had before, the 18.14%, that makes sense. And so there you go. And then find the percent of women who are no more than 65 inches tall. Okay, so look at this problem. It completely changes the raw data. So that means I need to do it all over again, because this one is saying who are no more. So this is just a fancy way of saying who are less than, right? No more than 65 inches. So less than 65. Okay, so it's basically, if that's one of my biggest hints. I would say, look at the words that they gave you and come up with something that makes more sense to you, and then after that, is it the left or the right, right? So it's 65 inches tall. So basically, I need to do this process all over again. Find the z-score, um, look at the table and stuff like that. Okay, so I'm gonna go ahead and do that. So for the z-score, it's raw score first would be 65 minus the mean over standard deviation, and then that is completely calculator now. So let me grab my calculator. 65 minus 64.1, and then divided by 2.75. So then that gives me 0. What is that? 327. Okay. And then the 2, again, it depends on what the number right next to it gives me. It's a 7, so that means it's going to go up. So it'll be 0.33. So that is the z-score for this problem here, 0.33. Now, once again, I just need to go to the z-score table and then figure out where this is. Okay, so I'm actually not going to do that right now. I'm just going to say what the answer is, and that's one way for you to practice finding the z-score on it. For those of you guys that did that, right, I believe that you should have gotten 6293, which is basically just going to be equal to 62.93%. All right, and then that'll be the answer for that one. All right, so let's go ahead to the next one. And basically what I just want you to do here is just understand this kind of random thing that, I'm pretty sure some of you guys have seen in like some of your test scores or something like that. Like a percentile, like, oh, you scored in the something something percentile, something like this sentence right here. Okay, well, I'm just gonna try and like show you, or like try to explain what that is. Okay, so a percentile rank is basically, just think of it as like all the people you kind of beat, or you kind of like scored better in, right? Let's be like, that's really what it is. So for instance, if you landed right here, then that means you beat this amount of people here. Whereas, if you would have landed, let's say, for instance, right here, that means you beat, 50% of the people, right? So it all depends. That's all it's really saying. It's just saying this is how much, this is the percentage of people that like you outscored or whatever, okay? So for instance, look at this question right here. All right, let's look at this question. What is a percentile rank? So right here, percentile rank. So you're really just asking for, what percent of people did you outscore of an SAT score of 450. So this is what you got. So 450, this will be your raw score. The mean is 400, and then the standard deviation is 27. So what you really just have to do is basically find your z-score, and then in that z-score, go to your z-table. And then basically the table is going to tell you what percent, right? Because remember, the table I gave you is the one that shows you the left side. So basically, all of these are considered the left. So that's what you're looking for. And so that just means those are all the sort of quote unquote people that you beat, really, or the scores, okay? And so that's all you have to do here. For this one here, the z-score, right? I already gave it to you, right? Well, this is not the z-score, sorry. This is what you would find in the z table after you find the z-score. So for me, let's see, it'll be 450 minus 400 over 27. I can do that math, kind of basic, but yeah. So 50 divided by 27. Yeah, I don't know how that one. It's like 2 point something. I'm not like 1 point something, but let me just do it for sure. All right, so it'll be 50 divided by 27. It'll be 1.85. 1.851. Okay. So since it's a 1 on the side out of the 5, it'll just stay 1.85. Okay, so it'll be 1.85. And so what that just means is you would go to your z-score table now, you would look for the 1.85, and then that will give you, that would technically give you 0.9678, but then you know that we can go ahead and convert it into like a percent and stuff like that. And so what you see there is basically now percentiles, you don't really say like, oh, you beat, or like you scored in the 96.78. No, people just round it. I'm not sure why, whatever. But rounding this number, I guess they rounded the tenths, who knows. But then it becomes 97th percentile. So what that means is that you scored better than 97% of the people that took this SAT, with average of 400, standard deviation 27. So that's really all it's saying. I mean, I guess you can just see it as like, oh, that's the people you beat, cool, whatever. So z-scores and percentiles. When looking at standardized tests, it always says you scored in the blank percentile. So for instance, if it says you scored in the 50th percentile, that just means you basically got the average, really. That's all that really means. Like you scored the average, stuff like that. And then think of it as like if you scored in the 80th percentile, that means you scored above 80% of the people, right? So that means you would land like somewhere right there. Okay, so it just kind of gives you a rough idea of where you would land on the bell curve, honestly. So what z-score puts you in the 99th percentile? Okay, so what z-score puts you in the 99th percentile? Well, let's go ahead and let's look at the z-score table. Let me zoom in for you. All right, so 99. So I'm trying to get to close to 0.99 as much as I can, okay? Now, if you notice, these give you four decimal places, right? Just try to focus on how to get 0.99 perfectly without having to, round or whatever. All right, so let's see. Where does the 99s begin? All right, so we have 98.71. All right, we're getting closer. 98.90. Okay, here we go. Look, found it. 99.01. Now, some of you guys might be going for 0.9898 and then 0.9901. Whichever of those two work, honestly, for me. I'll just take this one here just because it says 99 on it, but whatever, right? Because if you notice, the other ones also say 99, but then you're just getting further and further away just because, the other two digits are getting further and further away. So basically, that's the one I'm going to use, the one I circled. And so now look at your z-score table. How do you read that? What z-score would give us 0.9901, okay? So you got to look. Okay, so it's the 2.3, and then it's the 0.03. And so basically, you would just go ahead and add those two, and then that's how you basically just like mash them back together. So it'd be 2.33. So that'll be your z-score, okay? 2.33. So what z-score puts you in the 99th percentile? 2.33. All right, now if you notice, this z-score means you're 2 standard deviations away plus a little bit more. And it makes sense because, just think of the curve, right? Think of the curve that you're talking about. This is 1 standard deviation, this is 2 standard deviations, this is 3. Notice we don't even go after 3 because it's just so low, right? This is super not drawn to scale. So 2.33 would fall like somewhere right there. And so that means it's basically this big O like area that you need to cover. And there you go. That's 99% percentile. Let's go ahead and the answer's there already for you, but I want you to see if you can figure this out, okay? So pause the video, really give it a try, and then see what you end up getting. Okay, so let's see. For this one, it says you received your score on the SAT, and it says that you scored in the 75th percentile. Okay, so just already know 75th percentile means that in the table, okay? So in the table, you're at 0.75, okay? If the mean of the SAT you took was 1350, so mean is 1350, standard deviation of 50. What was your score? So we're actually looking for the raw score. So that's what we're looking for. Okay, notice that the answer is here already. So let me just ignore that for right now and let's see if I can get to it. Okay, so I have all the information. I have the raw score, or no, I'm sorry, I'm looking for the raw score. Notice based off of the things that I'm given, except for the 75th percentile, except for the 0.75, this is technically all in the z what is a z-score equation, right? Where it looks something like this. And so the only thing that we're missing is, let's see, we're trying to solve for this one here. So the only thing that we're actually missing that we would need would be the z-score. But then, the really nice thing about it is that the z-score is going to come from using the 0.75. It is not equal to 0.75. So be very careful with that, okay? So the z-score comes from the 0.75 in the table. So what we're going to do is, again, go to your table. We're going to look where can we find 0.75 in here. So that's the key thing, right? The 0.75 has to be found inside the table. It is not the z-score. So let me go ahead and 0.75. Let's look for it. And this is me really trying to just see which one is the closest one. So I see 0.7517, and then this one ends up being further away, so I'm not going to include that one. And then I see 0.7486. So technically, I would say you can use both of those because both of those will be rounding off to 75%. Because this one here, give me a second. This one here has a 1 next to the 5, so that means the 5 will stay, and then this one has an 8, so then that means the 4 will go up. So you can use whichever one you want. Like, I would be completely okay with both of them. All right, maybe, I don't know, like for higher level math, like, stats, AP stats, it'll be a little bit more specific, but for right now, this is fine. And so let's look at the z-scores. So remember how to use this table. You basically see, where does it intersect both of them. So it'll be 0.6, and then if you decide to use the 7486, it'll be plus 0.7, or we can use 0.6 plus, sorry, I totally messed up. That should not be 0.7. That should be 0.07, and then plus 0.08. So whichever one of these two, okay, it would be completely fine, right? This one ends up being 0.67, and this one ends up being 0.68. It doesn't really matter to me, honestly, unless you're giving me something that's super wrong, like 1 point something. Like, all right, cool. Like, where'd you get that from? All right, so I'm going to use this one just because whatever. It's the one I chose, right? It doesn't really matter. So 0.68. So that's the one that I'm going to use. Now, what that means, though, is that the z-score is 0.68. So 0.68. Okay, that's what it actually means. So now all I have to do is basically set up my equation and solve it just like I have in those other videos. Okay, so it'll be 0.68 equals to, and I'm following this equation right now for those of you guys that are maybe a little bit lost. That's what we're solving for, minus 1350 all over 50 here. And now we can go ahead and solve it like we did in the previous videos, put it over 1 and then cross multiply and then solve for x, okay? And I'm going to assume this is right. I'm not entirely sure. I haven't checked it in a while, but there you go, okay? Let me actually do it, whatever, out of time. So that, and then times that, which, I mean, I can potentially do it in my head, but let's see. It'll be 0, 40, what is that? 34, and then 1, 2, okay? And so then plus 1350 on both sides, plus 1350 because I'm trying to isolate the variable. And so then I end up getting x is equal to, what is that? 1384, which is right there. So there you go. I was right. I think maybe you would get the other answer if you would use 0.67. I'm not entirely sure. I think so, but like I said, right, whichever one of those two will give you the right answer.